That all the pre-processing steps are done, we will continue with the neural network. And this time you will observe there are two new types of layers. One is the embedding layer and the other one is the flatten layer. Now, if you all remember, embedding layer is actually used to convert the tokens into vectors. Okay, each and every token will be converted now into some meaningful vectors. Okay, vectors that make sense. Now, the input length for every vector is given as the vocab length plus one, right? Now we know the vocab length, that is the length of the unique tokens, plus one because we are using a new token called zero while in the padding purpose, for the padding purpose. So that's why vocab length plus one. And this value represents the output length, okay, the output length of the vector for every token, which is 50. So it's a hyperparameter. You can choose what vector length you want for every token. Now input length, which is max length, it represents the length of the document. Okay, it is the length of the document. And mask underscore zero is true. This means that zero has no meaning. Zero is just there for padding purpose, so it doesn't have any special meaning. After that, we use a flatten layer, and this layer is used to convert the two-dimension or three-dimension data into a single dimension, so that we can pass that data to the dense layer. And after that, as you can see that there are some set of dense layers. The final dense layer has one single neuron with with a sigmoid activation function. Okay. After this, as usual, we will call the compile function. We will provide an optimizer, the loss function. Uh, the target value is not in the form of numbers, so we will perform label encoding on the target value, and then we will call the fit function. We will pass the train matrix y train. We will train it for 5 epochs, and the batch size will be 32. So, okay, I think I did not run a few steps here. So the training is happening. So training is very quick, and all 5 epochs done. The loss function value is this much. Now we will call the predict function on the test matrix. Using np.where function, we will convert the probability value into 0 and 1, and then we'll see the classification report. And this report shows a great accuracy value of 99%. Okay, and the F1 score for both 0 and 1 is also 99 and 96% respectively. So using the neural network, we really have got great results. Correct? So guys, in the neural network, uh, in the architecture, everything is same. The process and everything is all same. The only difference is this time you have two new types of layers. One is the embedding layer and the other one is the flatten layer. So I hope all the arguments in the embedding layer is clear to you. That is, first of all, you will pass the vocab length plus one. Plus one is for the zero. The output length, the output vector length for every token, we want that to be 50. This represents the length of the document, and mask zero means mask zero equal to true means zero has no meaning. So all these are the arguments that you need to pass to the embedding layer. And then we have the flatten layer that converts the 2D or 3D data into one dimension so that we can pass it to the dense layer. So that's all from text classification using neural network.